computer. I don't know where it's going to go or if it's going to ask me. I don't see it asking. Oh, it just says I'm recording. So God knows where it's going. I'll have to go look for it. Okay. I am going to go here, share the screen, and I'm going to go through kind of a planning process, and I'm going to let everybody know kind of what I go through. I don't claim to be an expert at this. What I do claim is to have learned a lot over my number of years I've been here taking pictures, and I'm sure there's some of you out there that do better than I do. So anyway, this is going to be mainly on streak shot planning. Capture the rocket launches from KSC the Cape. So when you go out to do streak shot shooting, and I know I'm speaking to a wide variety of folks here, but you're obviously going to need a tripod, absolutely necessary, a sturdy one at that. Camera with a bulb mode feature for long exposures. And let me just pop this out of my way here so I can see. There we go. For long exposures and manual controls and so on for f-stop, aperture, and ISO. You should have and I put this in air quotes here, a wide angle lens, okay? An intervalometer, spell that 3 times in a row, or some way to manage shutter controls. And I'll talk about some of the options you have in that regard when we get to it. This was the control print screen or snip or whatever. These are some of the URLs that I'm going to go to during this presentation and show you how to use them. So if you do a control print screen, you will have these 6 URLs handy and written down. And once you get there, you can save them as favorites or do whatever you want. And this is why I was saying earlier, I don't think a pen and paper is going to be the most practical other than getting the first main word. But these are where we're going to go and just take a look at some of the planning capabilities and tools that are out there. Okay. Anybody still stuck on this, or can we go on? Okay, we're going to go on. Okay, different perspectives. And this is one of the things that I want to make sure everybody understands. You have obviously shooting and catching the streak right to left or left to right. Are you going to want to catch it cutting across the sky or arcing off into the distance? Believe it or not, time of day has an effect. If you're right after sunset or right before sunrise, very often you will have the rocket launching in nighttime, which you think is, oh, streak shot, only to find out that after passing about 4,000 or 5,000 feet, the rocket flies into daylight because it flies past the shadow point of where the sun's rays are being shadowed by the curvature of the Earth. So that is something to think about. We had a perfect example of that about a week and a half ago when SpaceX launched the Crew 2 mission, and we got all those absolutely mind-blowing effects of it looked like an octopus or an egg or whatever. All these kind of images we were seeing in the sky, and believe it or not, all those images happen every time. But the problem is it's either daylight and you can't see them, or it's nighttime and you can't see them. But when the rocket launched just before sunrise, we're looking at the rocket, your eyes are adapted to nighttime, and then it flies up into the daylight, and we saw all that happens on every launch, but we never get to see it unless you experience that day-night kind of occurrence that occurs right around sunset or sunrise. I'll have a little discussion about a tail chase and a couple other things. Okay, this is all of our launch pads. There's a couple more coming online soon. Where the launch pads are, and obviously the observant among you will notice that this is a Google Earth map, and you can see that. Can you guys see my mouse going?
I can't see it.
I see it.
Okay, that's going to be hard because I was hoping that my mouse would make for a good pointer, but
I can see it.
It's
You
on
can see.
41. Yeah.
I can
yes,
see it.
it's right around
41.
pad 41 right
41.
now.
Yeah,
Okay.
pad
Oh, okay. It's a
41.
very tiny mouse.
It's a very small mouse. So, and I suspect there's a little bit of lag, and I'll try and compensate for that. But if I need to point to anything on the screen, I will try and use my mouse slowly and take my time. Okay, so these are all the pads. The pads you are going to see most often are up here, pad 39A, which is where SpaceX launches many of their Falcons from, and anything with astronauts is going to go off of 39A, or any Falcon Heavies where they strap 3 of them together, that's going to go off of 39A. You won't see anything off 39B for a while. That's going to be the Artemis, the SLS rocket. That's 2 to 3 years away, I think. Skipping on down to pad 40, that's SpaceX's other launch pad, and that's the one that's on the Cape. That's also a Falcon 9 launch pad, but there will never be astronauts off that. That is not a human rated pad. 39A is and 41 are, but 40 is not. So in between those two is pad 41, where ULA launches their Atlas, and they're getting ready for their next rocket, the Vulcan, and it will also launch from pad 41. The Vulcan, hopefully we'll see the first one sometime later this year. Pad 37, which is a little bit further south, the next one down, that's where ULA launches their Delta IV. And they used to have a Delta IV medium, but they're not going to have any more of those. There's about 2 Delta IV heavies where they strap 3 of them together that are going to launch over the next 3 years, and they'll be going off that pad, and then ULA is giving up the pad. The 2 great big huge towers that you guys have seen grown out of the horizon, that's pad 36. That's where Blue Origin will be launching, and that's down right where my mouse is circling now, near the tip, but not quite the tip. The tip is pad 46, where SpaceX launch, or where Space Florida launches a couple of items. Okay, I went out on a limb and decided to do some animation. So I'm going to click.
Hey, Gordon,
Yes.
I got a question for you.
Yes, sir.
From the pad 46 to 39B, what is that distance?
That's
a
about
long
10
way.
miles. That's
How
about
many?
10 or 12 miles.
Okay.
Yeah, that's a long way. This white area that you see, that's the Air Force Station, is 16,300 acres. So like when I come into South Gate, which is right down here, driving my car, and drive to my office, which is right there where it says Cape Canaveral, right in there, that's about 6 miles. Okay, from the South Gate to there is 6 miles. So anyway, okay, that is a launch trajectory of 038 degrees. That's about as far north a launch trajectory as you're ever going to see. Because if you get any further to the left of that, you're overflying the Carolinas. So you can't do that. And so 038 is about as far left or as far low a launch trajectory, launch azimuth as you will ever see. Normally, it's somewhere in between. 080 is looking like that. And I'm making these all look like they're coming off pad 40 because tomorrow morning's launch is off pad 40. So it'll kind of give you a little bit of a reference as far as that goes. And the very southernmost direction is about 140, give or take. You very rarely see that. SpaceX had one last December, I think it was. It was a polar launch. It was the first polar launch off the Cape since 1968. And the reason is if you fly out here and continue, you overfly Cuba and Bahamas and places like that. And the last time we did a polar launch, we had a malfunction in 1968. It crashed in Cuba and killed a cow. And so that put a political kibosh on polar launches. And then what SpaceX does is they launch and they head down this way on this 140 or thereabouts until they're past the Cape, and then they dogleg. and someplace down here below the Cape, they'll actually turn the rocket and fly about a 155 or thereabouts, which will help them avoid overflying land masses where they shouldn't. The problem with that, obviously, is they're burning a lot more, significantly more fuel to do that. So SpaceX, just about anything that happens with SpaceX, sooner or later comes back to dollars. And so that's a big question there. Okay, so your viewing perspective. This shot, you guys may remember, I took first place back in April on that shot right there, and it's got the arc going up. And again, this is a right to left arc, and you can see it going up through the sky here. And if you look up here on the map, that's approximately the view that I had. So I knew that SpaceX was flying about a 042, which is that purple arrow there. And I knew that that was their launch azimuth. And so decisions on where to go to take the picture start with knowing what that launch azimuth is. And I knew I wanted to get the Milky Way, which required excessive darkness. And I knew I wanted to get around at 90 degrees. So I was up here just north by the north gate of the Canaveral National Seashore. I had to go up to Ormond Beach and come south to do it. But that was my view. So if you can see that, we're talking about launch perspectives. I'm looking almost 90 degrees to that particular azimuth. And that's the type of view I can expect, where you see the complete arch like that. Okay, here's another one where I'm looking, it's not quite 90, it's in between. But in this particular case, I took this shot. This was an Atlas, and the launch azimuth was about 080 or thereabouts. And I was down here by the Cocoa Beach Pier. And so I took that shot. And this was another one, by the way. This is a perfect example of the rocket launching at or just a few minutes prior to sunrise. And you can see the sunrise just starting to happen over there and flying into the sunlight. So that's why all these exhaust plumes of the rocket and everything up high are lit up white, because that sun is lighting them up. So that's a perfect example of one of those times when you're near a sunrise or a sunset. Anticipate where the rocket's going to go. Is it going to fly into the sun, the daylight, or fly out of the daylight, and those types of things. And that's just a matter of noodling through it and figuring it out. Okay, here is a somewhat of an acute angle, and I took this picture just about where this yellow arrow starts here, just a little bit north of the NASA Causeway. And I knew, again, SpaceX was flying about a 043 or thereabouts. So I did that on purpose because I wanted this type of view where the arches up and away, but it doesn't spread very far left or right. So I wanted a portrait orientation, and I wanted that type of view. And so that's where I set myself up to get the shot. Now, this is where I'm going to talk a little bit about a tail chase, and this is a hypothetical, but what would happen if I decided to go down in this area here in the middle of Merritt Island, set up shop and take the picture, knowing that SpaceX is going to have about a 043 launch? What would I see? I would see that rocket go straight up and turn into a dot. And that's it. I would see no arch, no arcing at all, because I'm shooting straight up the tailpipe of the rocket and there's no left or right movement in the rocket. So this is what I'm talking about when I'm talking about perspective. Understand where the azimuth is going and understand how to get there and what type of angle you want on the azimuth. And we'll talk about that a little bit here in just a second. Okay. How do you know what azimuth the rocket will have? Easy for me. I call up the flight planner and say, what's their azimuth? But for everybody else, they have to know how to do that. So this is one of those URLs, one of the first ones there, space launch now, me launch upcoming Florida. And I am going to go over, let's see here. I am going to go to share screen, and I am going to go over to
Why don't you just give us the phone number?
The phone number? Is it this one? Yeah. Okay. So, and no, that's not what I wanted either. Let's see here. A new share. I want this one. Let's try that. Now I'm going to take that down. Yes, this is where I wanted to go. Yes, no, no. Yes, this is where I wanted to go. Okay. So when you go to that URL, you'll come to this website. Everybody see where it says Florida launch schedule? Are you seeing that?
No,
No, we're seeing a rocket launch.
we're seeing a Photoshop screen.
Okay. Let's try that. How about
Florida
that?
launch schedule.
All right,
Yeah.
that's it. So when you go to that URL, you'll go to this Florida launch schedule, okay? And it'll give you all the launches coming off of the Cape or KSC. And as you can see, it lists them all in chronological order of what you're going to see. So let's take tomorrow morning's launch. It'll give you very basic details here. So you go over and you click on Explore, this little blue rectangle in the bottom, and it'll take you to this page here. It'll give you the countdown, the date, and all that type of stuff. And you scroll down a little bit till you see telemetry, in-flight club. Okay, you click on this very dark blue link here, and it'll take you to a whole bunch of very technical looking displays like this. Okay, and this here, you could probably get a master's in aerospace engineering if you just learned everything on this page. However, we're not going to do that. There's only two things we really want to have. And one is azimuth down here. And this particular azimuth screen will show you the launch azimuth from north going up and launching. And this all sounds very complicated, but it's really not. And on all of these shots, because it's a Falcon, the very first little orange dot is basically MECO, where the engine shuts down, first stage. So you can see here, starting at about 14 seconds, 12 seconds, the rocket pitches over and it tracks along this particular course. And if you look down there, coincidentally, first stage and second stage are tracking the same azimuth. It's a good thing because they're connected, but they're tracking along, and it's 41.3, and then it'll get up here and it'll get 42 point something. So it's about 42, okay? And you don't have, this doesn't have to be really hard and fast, but it's about 42, okay? And that first little orange dot, you can see it pop up there where it says trace one. If you look at the bottom, the marks along the bottom are time in seconds. So this is one of the things you want to write down. Is MECO happens, and MECO is where about the end of your streak shot is going to be. Happens at 159 seconds, okay? So that's 2 minutes and 39 seconds. So that's about where MECO happens. So you've got the azimuth, call it 42, and you got the time of 159 seconds. So that's really all you need from this graph right here. Does everybody see how you do that?
Are you just hovering along that line with your mouse?
Yes, you just there's a little crosshair like you'd see in a rifle scope, and that crosshair you just hovered along, and those things pop up on the screen and show you the launch azimuth in degrees. And at the very bottom, the little number that pops up this way, in this case, it's showing 159, tells you along the bottom axis, time in seconds. So at that first point of interest, which is MECO, 159 seconds. Okay. So that's the first piece of information you want off this particular website. The second piece of information you're going to want is how far down range are you at MECO? So very up at the top where you see the word profile, does everybody see profile? You are going to see in profile, that first point happens right there. And there's two numbers you need to get from this, okay? The bottom number is 84.89, so call it 84.9 kilometers downrange. So you write that down somewhere. And the other number is the altitude off to the left, 61.9. That's 61.9 kilometers in altitude. You really don't care about the altitude, to be honest with you, because it's not going to matter. You're not going to do anything with it. But what you do want is that downrange kilometers. Okay, so that's about how far downrange it's going to be when the main engine cuts out. Okay, so that URL that takes you to this page, and you do the 2 clicks to get here, those are the only 2 things you really need to get. Is you need to get the azimuth down here, and you do that by hovering over it and getting it, within a couple degrees is really all you need. And the profile, how far downrange in kilometers you're going to be. So if it says you're going to be 84.9 kilometers downrange, one of the things you want to do is go over to Google, and I'm clicking over there now, and you put in here 84.9 kilometers on the left, and you get 52.7 miles. So it's about almost 53 miles downrange. Now, this is just one of the URLs I showed you. It's just a tool in the Google suite of tools that converts stuff. You can convert kilometers, miles, and you can convert seconds to minutes. There's all kind of length, everything in here. Google does all these conversions for you. So anyway, this one here, you just want to get that kilometers to miles. Okay, everybody see that? All right. Now I'm going to go down here to new share. I am going to go back to where I was, if I can find it. I think this is it here. Share. Okay, so that's where we left off. This is a representation of azimuth and profile, the 2 that you're going to use. And again, you're interested in this number here in your azimuth, which is going to be reading on the left scale, but you highlight your mouse over the top of it and the azimuth will pop up. Over here on the right for profile, you're interested in how far downrange you are. And I've just gone through all that, so you know that. Okay. Foreground and or background makes a big difference. A streak shot in pure darkness is boring. Use foreground items of interest to give perspective and interest in your overall image. Light painting with a flashlight is an excellent way to bring out details of foreground items. Does everybody know what light painting is? Does anybody not? Light painting is when your shutter is open in a very, very dark environment, and you take a flashlight or some other artificial light and you paint your subject with the flashlight beam. And so as you paint your subject with the flashlight beam, that reflected light will come in and register on your sensor, and you will have, voila, light painted your subject in a very dark environment. So you'll see that a little bit later. I will have a demonstration of that. Pay no attention to that jumping back and forth. That's just me. Okay. I am going to go to new share. I'm going to go here. Okay. I've taken you to Photoshop. Okay. This is my Photoshop here. And here is one of the shots I took of that launch. And it was one of the ones that I showed you earlier. And this is what I say when I say when you have a streak shot that just is in the middle of the night with nothing else around it, it's kind of boring. It's a nice streak shot, but it's kind of boring. So what you want to do is you want to, with your camera on the tripod and the position of your camera locked down, you want to change your focal point, your ISO, and your shutter speed and your aperture and things need be to get other items in the shot. So by rearranging, I was able to get a reflection on the water. Okay. And this is just what would happen if I changed my view in the camera. Okay. So you want to anticipate you're going to get a significant reflection in the water. But if you look over here on the left side of the water part, there's all this stuff going on that would make a great foreground interest if you were just to light it up. So before your streak, this is all happening 10, 12, 15 minutes before you get the streak, before the rocket goes. When the rocket goes, you're doing nothing but letting it capture the rocket streak. This is all in anticipation, either before or after the rocket goes.
Gordon, so you're creating layers to layer in Photoshop at different times.
That is correct.
Okay.
I'm creating layers. You can do this in one shot, but it's difficult because you have to have the light. You have to be madly light painting your foreground if it needs it. Or let's say you're launching at a particular time when you got a full moon behind you and your full moon is illuminating all your foreground for you. Okay, so you can do it. This is the technique of adding layers and then putting them together in Photoshop. So if you watch the dock area here, as I added layers, I took my flashlight out and I did a bunch of light painting. And I got the dock lit up. And so that wound up being pretty close to my finished picture, where I have the dock in the foreground, which is the foreground interest for the streak shot. Now, like I said, your camera's on your tripod. You're not moving your camera at all. And so what I did is I had focused my camera on the dock, this little fake owl up here or something right here on the dock. And I took this picture probably about f8 and probably about 800 ISO. I don't know off the top of my head, but probably about 800 ISO and about f8. And I just opened it up for 10, 12 seconds, whatever it was. And I would light paint. Okay. And I would just set my camera to just do that over and over again. And I would just stand around for about, I don't know, 4 or 5 minutes painting the dock, okay, with light, and knowing that some I'm going to, paint too bright and I'm not going to be able to use it. Other times it may not be bright enough, but I'm going to get a number of exposures. And so I will pick the best ones and use those to build my layers over here that I will layer on the final image. Then what I did is I got inside of about T-4 minutes. I then took, without moving the camera, I changed my settings on the camera and I set my focal point on the far shore, which is basically infinity. Okay. I changed my ISO to 100. I changed my setting from manual to bulb because I was going to leave the camera open for 2.5, or the shutter open for 2.5 minutes. Okay. And I changed my f-stop down to, I think it was f18 or f22, somewhere closed way down, because that, I'm here to tell you, that is brighter than you can possibly imagine. So that was roughly my settings on that. I had bulb, I had f22 or f18, f20, somewhere in there between f16 and f22, somewhere in there, and ISO 100, as low as your ISO can go. And then when I saw the glow, the sudden burst of the ignition of the rocket, I locked the shutter open and just enjoyed the show for 2.5 minutes until I saw Miko up here and I saw it burn out, and then I closed the shutter. And that's all there is to it. All right. I am going to close this. I don't know if I should do that. Let me
Gordie,
go
I
back
have
here.
one question.
Yes.
You waited for the rocket to actually ignite, or did you
Yes.
time your camera like
No.
4 seconds before the beginning?
No. As long as I'm by my camera, I just wait for the rocket to light, and then I press and lock my shutter on bulb and just let it do its thing. The only time you have to time it is if you can't be by your camera and you synchronize your watch and your timer and all that kind of stuff, in which case I'd give myself time ahead of time to let it go if you can't be near your camera. I don't know, unless you have a remote camera set up on the Cape near the rocket, you're not going to really have that. As long as you're going to be near your camera, all you got to do is wait till you see it ignite and away it goes.
And you don't add seconds to the end of Miko.
You can
You
add,
can't. Nothing would happen to the picture.
well, the thing is, once it burns out, all you're taking a picture of is the black sky. So you're going to get a little bit more star movement and things like that. Let me talk about that again. Remind me to talk about that again, okay? Because I got something else that I can discuss with that.
Okay, thank you.
That'll be more pertinent. So, okay, anybody else on this? Okay, let me go back to here. Okay. This is probably getting into more of your meat and potatoes of what you guys were interested in. How to determine what is the correct lens for your streak composition. So let me talk about lenses just a little bit. A wide angle lens is a relative term, as we all know. 85 millimeters is a wide angle lens compared to 200, but generally not wide enough for streak shot. But it all depends on your distance from the rocket launch site and profile. If you're inside of 10 miles, you'll probably need a 16 to 20 millimeter range lens. You can make exceptions to that depending on what you're trying to do. If you're interested mostly in the foreground and all you want to see is the streak going through your background, you don't need that wide an angle. If you're 10 to 20 miles, anything from 20 to 50 will generally work. More than 20 miles, longer lenses will work, but be sure to consider foreground and other items in the image. For example, that picture I took along the beach where it was going through the Milky Way. I'm going by memory here, but I'm thinking that was about either 24 or 30 millimeters, something like that, because I wanted the wide shot of the Milky Way, and I knew that my streak was going to be just a small part of it going through the middle. So when you start getting more than 20 miles away, your foreground and everything you're capturing along with the streak is far more important in your lens selection than the streak itself, because you could probably go 100 millimeters or more if you're that far away. Okay, a good place to determine your lens coverage is a field of view calculator. This is a good one at Bob Atkins, and we'll go there for just a second. Let's see here. If I could make this thing here happen again. New share. I want this one. Okay, so one of those URLs is this Bob Atkins, a field of view, and talks about rectilinear versus fisheye lenses. And he goes, I mean, there's a whole web page here, and it goes into PhD level calculus and refraction and diffraction and all kinds of stuff, of which if you're curious and you can't get to sleep someday, you could read it. But in reality, calculating field of view, which is about almost halfway down, is this little active chart here. So in the upper left corner, I am going to put in 16, okay? So I'm going to use a 16 millimeter lens. I put it in there, then I hit calculate. Okay, did everybody see that? Did they see the numbers change? Okay.
Gordon,
Yes.
can you put different format sensors into that equation?
Yes, I will get to that.
Gotcha.
I knew you were going to ask that. Okay, so 16 millimeters, and you're going to get your horizontal field of view is 96.7 or almost 97 degrees. Okay, your vertical angle, okay, your sensor is a 2x3 sensor. I'm not talking about Richard, but everybody else in the world, 2x3. So the vertical angle is 73.7 or almost 74 degrees. So let's say you have a camera and the lowest or the widest angle you have is 24 millimeters. So you put 24 in there and you hit calculate, and it'll tell you your field of view is 73, almost 74 on the wide and 53 on the short, on the up and down, okay? All this is based on having a full frame camera. And this is what Richard was alluding to. So let's say you're shooting with your Nikon 7250 or your Canon D90 or whatever, and you have a sensor size factor, okay? So I'm familiar with Canon. So they have a sensor, their crop sensor camera. It's got a 1.6 factor right there, okay? And if I hit calculate, notice I haven't changed. It's still a 24 millimeter lens, okay? All I've changed is my camera sensor to a 1.6 because it's a crop sensor camera. I hit calculate and look at how much the field of view of your camera has changed dramatically. So if you have a crop sensor camera, you should lean towards a lower focal length. So you may think you can get away with 24 or 30 because you're 15 miles away. You better go with maybe the 16 if you're using a crop sensor camera. So those are the types of calculations you put in there. Richard, what's yours on your Olympus?
It's a micro four thirds.
Okay.
So the factor is 2.
2. Okay, let's see what that does. Okay, so there you have it. You have 41.1 by 28 degrees with a factor of 2. Okay. Now, you still put in your camera's focal length, your lens's focal length here, and then you should know what your camera is. You put that in once, there it is, and then you hit calculate. What I would do is build a little index card or cheat sheet or something and put in common focal lengths for your camera in here and write them down. So for example, I have one lens that's a 16 to 35. I have another that's a 24 to 70, and I can't see myself using more than that, but maybe every 10 degrees or so, put it in here, find out what these two angles are, and put it on a little index card, and that'll help you out. Okay. Now, have I lost anybody? Has anybody lost? This.
I have a question, Gordie, about
Yes.
the distance to subject. What is the 6?
That it's irrelevant. Okay. The reason is because what it's telling you is if you're interested in something other than degrees, like if you're interested in the actual distance, if you put something, your subject is 6 miles away, in this case, you're going to have 4.5 miles by 3 miles. That's how big your spread is going to be. Okay. If you're 6 feet away, you're going to have 4.5 feet by 3 feet. So this is just for figuring out what your field of view is in actual measurement. And for streak shots, you don't really care. You just want the angle. How wide is your angle, is your lens view? Do you follow me?
Okay.
Do you follow me?
Yeah, it doesn't change the distance because it's still the same angle.
Right. The angle doesn't change. Okay.
Okay.
This says distance to subject in any units. So whether this is 6 miles or whether it's 6 inches or whether it's 6 feet or 6 yards, it doesn't matter because the answers are going to be in the same, whatever the same unit is. If this is miles, these are going to be miles. If this is feet, these are going to be feet. And if the distance to your subject is 24, then this is going to be how much of that is going to be exposed, 18 by 12. Okay. So whatever the unit is and how far away, and that's why this is really irrelevant. You're more interested in what the angle is because you're going to capture this thing and it's going to be 10 miles away or 12 or 8 or whatever it is. You're interested in the angle, and that's what we're going to get into that here in just a minute. But you're mostly interested in the angle. Okay. So the
Okay.
things to know here are the focal length of your lenses and whatever the multiplier it is on your camera. And again, if you have full frame, it's 1. If you got a crop sensor, it's 1.6 for Canons, 1.4 or 5 for Nikons. It's 2 for Richard's camera. So whatever your crop factor is. Hang on, I got to yell at Walter.
The crop factor for lenses Gordon's referring to is typically known as APC sensors.
Yes,
You may be familiar with that.
right. So APC sensors, and that's a crop factor from what is the industry standard, which is 24 by 36, which is considered a full frame. And it's only full frame because that's what film was back in the day. Okay. Let me go back to where I was. Okay. That was my note down here. Be sure to correct for non-full frame sensor sizes. Okay. Okay. This next one is, this is one of the best tools in the shed. This is the meat and potatoes of what you're going to use. The URL is in one of the URLs up there. It's called the Photographer's Ephemeris. Walter, shush. And this is a website. Now, it's free. There's a free version. Or you can pay $4.95 or whatever it is, indefinite, and you can get it on your cell phone and work it on your cell phone. I have it on my cell phone. Gives me a couple more options, but there's the free version is also out there on the web. So let me go back here to change share. Go here. And now I'm going to the Photographer's Ephemeris. Now that's where I am. This happens to be centered right now on pad 40, which is where tomorrow morning's launch is going to go from. I have this set up in the upper left, tomorrow morning's date, 9th of May. This slider at the bottom, I have it set for 2:42, which is the launch time, or 2:43. But if you put your cursor over that little donut there, you can slide this to different parts of the day. So take a look what happens as I slide in later in the day. You see right there, you start to see a yellow line up here. Can everybody see that? That yellow line is where the sun is. The sun comes up on this line, this big heavy yellow line, but the small yellow line is where the sun is below the horizon, but it's starting to affect your photography. So you continue on until you get to sunrise, and at sunrise, bam, you got now golden hour, okay? And as you trace through the day, you will see that yellow line go around and around. That's where the sun is at any given time during the day. And you can take that all the way around until you get to golden hour again. And then bam, right there, sunset. But as everybody knows, sunset doesn't mean it instantly gets dark. You have the past sunset lighting, blue hour, if you will, and you can see that the very narrow yellow line is there, and it shows you where the sun is after sunset. Okay, so all this is it's a celestial display to tell you where the sun and the moon are at any given time during a day, at any given point on the earth, at any given date. So those are the things you want to put in. You want to put in where you're launching from right here, and you want to put in the date over here, and then you slide this over to launch time. In this case, it's going to be 2:43. So there's 2:43. So at launch time, I can look and I can say, well, both the sun and the moon are below the horizon. So I'm not going to get any contamination of the sun or the moon. What would happen if it was a full moon coming up or a pretty good sized moon coming up and it was over in the northeast or in the east or whatever? You might want to take that into consideration in choosing where you're going to shoot from. All of this stuff that I've been talking about is helping you decide where you're going to shoot from. Because let's face it, rocket goes up on the Space Coast, you can pretty much see it from anywhere. But all of this is to help decide where you're going to shoot from. You may not want to be shooting straight into the moon. If the moon is only 20 degrees above the horizon and the rocket's going to go up, you don't want to be shooting straight into the moon because you won't get a decent shot. Time to think about a different place to shoot from. So that's one of the reasons why this is an extraordinarily handy tool. And as you move your mouse wheel, you can zoom in on whatever it is you want to zoom in on. And because this is a Google Earth extracted thing, you can see that it'll get in all the way where you want to go. Okay. So what next? Over here on the right, okay, the little red pin is this red pin here. So that's where you will put the red pin. Hold on. That's where you would want to put it for whichever launch pad. There's 39B, 39A, there's 41, 40, and so on. So you would put the red pin at wherever the launch is going up from. And that's one of the reasons why I put all the launch sites on the map there, so you can see approximately where each launch site is. And then when you get in here, you can just transpose and it'll show you the launch site. Now you say, I want to shoot from, because I know tonight's launch is going to be going up roughly like this, about 0.42. So I want to get a curving shot. I want to get a nice arch. And so I want to be over here along US 1 in Titusville somewhere. Or maybe I want to be by the Max Brewer Bridge. Or maybe I want to be on the Playa Linda Beach Road out here. So you think about where you want to be, where you're going to get an interesting foreground. Maybe it's a dock, maybe it's a sign, something where you want to be able to get foreground interest. And that's why we talked about foreground interest. So you
Hey,
put the
Gordon,
red.
I got a question for
Yes,
you.
sir. Yes.
You mentioned the Playa Linda Beach Road. I remember they used to close that off for shuttle launches. Is it open now?
It's open for these launches because the FCA, the flight cautionary and flight hazard area for a Falcon is nothing like it was for the shuttle.
Okay.
Okay. So right now it's still open for launches, based on when the park is open, but that is open as of now. I suspect when they launch the SLS, that'll be closed. If they have changes in the safety parameters of the launches, it may close, but I doubt it for a Falcon. I just don't see it happening. So anyway, that's the red pin. You put that where it's going to launch from. This gray pin, I'm going to click on it and watch what happens. You're going to see a pin show up right there out in the ocean. See it? Okay. That's telling me that pin, if you look down here at this little black bar, is 12.15 miles out, and it's 79.75 degrees out from the red pin. Okay, so you see that? These numbers here tell you where that pin is. Now, the beauty is you can click and hold your mouse and drag that pin anywhere you want to put it. So let's say I want to shoot from the intersection up here on the Playa Linda Road, right there. Okay. Now I'm going to zoom in just a little bit. It's hard probably for you to see, but there's a gray line that goes from the gray pin to the red pin. And that's telling me I'm 13.04 miles away and I'm at 295.62 on the bearing. So that tells me what I am, this pin to this pin. So where this comes into play, let's say I'm going to shoot from the park that I shot from before. When I shot that shot, I drag the click and hold, drag the pin down here. Okay. Now I zoom in because I can zoom by just moving my scrolling mouse here. I can drag the pin to wherever I want it. Every time I let go, it recalculates. Okay. I can zoom in a little more, drag the pin down. Drag the pin down. And here is Kennedy Point Yacht Club is one of the places I took the shot from. So I'm going to put that pin right where I'm going to be shooting from. Okay, there's the pin. And let's say I'm going to be shooting from right there. Okay, so I put the pin right there. And that's where I'm going to shoot from. That tells me I'm at 13.3 miles from the launch pad, and I'm at 268 degrees bearing from the launch pad. So you say 13.3 miles. Okay, 24 millimeter lens probably work. Okay, based on those kind of wags I gave you earlier. So you know what kind of a lens you could possibly use. You know, you're in the ballpark. And you also see on this gray line, I don't know if you guys can see it very well, but there's this gray line that tracks straight to the launch pad. Okay. So you know that in the foreground, you're going to have all these boats. Okay. They would make an excellent foreground item of interest that you could light paint and everything. You could open your shutter, run out on this dock and light paint them from the side. You can do all that kind of stuff. Okay. So that kind of helps you understand where you're going to do light painting. But you got to remember, as the rocket launches, it's going to be traveling from right to left. How far is it going to be traveling? That's where we're going into the master's level on this particular program. So I'm giving you an example of this little spot at Kennedy Point Park where we're going to shoot from right there. It's actually this Kennedy Point Yacht Club. That's where we're going to shoot from. And you say, well, how do I know if when I open my lens, if I set up my camera, how do I know I'm going to catch where Miko is? Miko's out here in the ocean somewhere, right? But you remember from before when you wrote down, it was 042 degrees and it was 53 miles, right? So remembering where we put the pin, let's now click, hold, and drag the pin. And let's put it out here somewhere. And let's put it out about here. And that says distance 42. No, we want 53. There's 53. Okay, so there's 53. And bearing 43. Now we want about 42. So I'm going to move it just a hair to the left. So 42, right about 41.34. So there's 42, 51. We're going to go out just a little bit further. So where that gray pin is now is exactly where the Miko is going to be. That's where the rocket motor is going to burn out. And remember, the rocket motor burning out is about what you're going to catch on the end of your camera. The end of the streak shot is about where the rocket motor burns out. But if you look at it, that point from the park where we were before, we were at this park right here, from the launch pad to where I was looking, and the launch pad to where that pin is quite a distance. Well, what's the difference, right? One was 260, what was it, 267? Okay. And so what is this one? We have to figure that out. So rather than get out your slide rule, this particular program has a really handy feature. Again, over here on the right on the toolbar, you see where it's got the red and the gray pin with a little swap. That allows you to swap the pin. So I'm going to click that once. I don't have to click and hold, just click it. And now the red pin is where the rocket motor burns out. The gray pin is where it launches. Well, you know where it launches. You're not interested. You already had that number, 267. So I'm going to click and hold the gray pin. And I'm going to go back over to the park. And I'm going to put my gray pin back where it was before. Got to find it again. There we go. It was right there. Okay. So now you know that when the rocket motor burns out, it's going to be 62.53 miles from where you are. Okay. But the bearing is 230. So what's the difference between 230 and 267? 37 degrees, right? So your lens has got to have 37 degrees of coverage at a minimum. So we go back here. What was your coverage? Oh, I'm using a 24 millimeter lens. I'm going to use it in portrait orientation. So I'm going to get 53 degrees of coverage on my lens at 24 millimeters. Okay. But this is telling me all I need is 37. So that means when you set your camera up, allow a little bit to the right and a little bit to the left, and add 37 degrees of exposure where your streak shot is going to be right smack in the middle of your 54 degrees of view. And does this explain why it doesn't, does this help you understand why it doesn't matter what the distance or what the, you know, what the 2, the 4, the miles, the feet, that doesn't matter. All you care about is angle. And so in this case, you're getting 37 degrees of angle. And so you just have to make sure when you did this, or when you pull out your index card with the numbers on it, that you have something of 37 degrees or more. And I would say more, because you want a little to the right and a little to the left, give yourself some wiggle room. So something in the 53 degrees from 37, you want about 7 or 8 degrees on either side, and you're good. Now you're perfectly set up for where you want to shoot and how you want to shoot it. Okay. And when you do that, now you know you've got your right angle. So if you go through all this, okay, and you go back to this and you don't have enough coverage, you say, well, I guess I can't shoot it in portrait orientation. I'll turn my camera to landscape orientation, and I got 73 degrees. So I got plenty that way. The only risk you run there is it going to fly out the top of your frame? Okay, which is possible if you're in a little tight. That's possible. And the only way I know to figure that out, remember I told you really don't need the height. It was so many miles, 38 miles high. So if you get out and you do an arctangent calculation of this distance and that height and carry the one, you could figure out whether or not that angle is going to get covered or not. I don't do it. I'm not that into it. So anyway, that's what you can do. But this photographer's ephemeris is an enormous help as you get ready to shoot. So I'm going to put this back, and I got and by the way, because I got I paid my $4.95. I've got these preset locations here, so I can just hit go, and it takes me back to pad 40, because I've got 40, 41, 39. I got them all in there. So that takes me back. So I'm sitting here thinking, where do I want to shoot from? And what kind of angle, what kind of perspective? If I shoot from where this is, I get that same perspective as I showed you before, where it's arcing away from you, but you don't get the really broad perspective. You just get kind of the short arc perspective because it's flying away from you. If I wanted to get a wider perspective, I might click and hold, move this green or gray pin over here on Playa Linda Beach Road, and I know that the entrance to the park is right here and the gate is right here. So I know that if I go down here, I could set up at this intersection right here, and I will have a different perspective because I'm now shooting at this angle, okay, 307. It's going up at 042, so I'm much closer to 90 degrees. Not quite, but I'm much closer to 90 degrees. So that's why thinking about perspective, thinking about distance, thinking about where you're going to go, what do you want in the foreground is all very, very helpful. Now I'm going to go over here to Google Maps, okay, and hopefully you guys will be able to follow along. I am going to go into that point that I just put it. I'm going to zoom in, and there's that road that I just put the pin on, right? And I'm thinking, well, is there anything of interest there? So I go down here to the lower right, grab the little guy. I think you've all probably done this at one point. Click and hold, grab the little guy, drag him up there, and where that green circle is, let go. Now what I have is the view if I was sitting there. There's my car. And I look around here and I go, well, look, there's a sign there. I'm going to move back a little bit. And I would be, the rocket's going to be going up right around where my cursor is now, my little hand. And it's going to be arching again, right to left because of where I am perspective wise. So it's going to go up and go over like this. Okay. Well, look at that, Canaveral National Seashore. Wouldn't it be cool to set my tripod up right here, looking down here? I know my view is wide enough, so I'll put the right edge of my viewfinder maybe by that tree because I don't need anything to the right of that. And I know it's going to shoot up here and go off. I know I got plenty of angle to capture it all. And I got this really neat sign that I can put in the foreground. And when I set up my camera, lock it down, I can take a whole bunch of pictures of this sign using the flashlight and everything else, getting it just right. And then at T-4 minutes, I can go back to 100 ISO, go back to focusing on infinity, go back to bulb, and just catch the streak. And now I can layer one of these really cool pictures of this sign underneath the streak, and I get a great composition of what it was like. Does everybody follow me on that? Okay. These are just some of the tools that are available for you to go through and use as you prepare for a launch. And I know I'm probably really going faster than I need to. But that is Photographer's Ephemeris. That is probably the most important tool that I use, is right there. Okay. Next thing, what will the weather be like? There are a million weather apps out there, partly cloudy, mostly cloudy, or you could get an aviation weather, 2500 scattered, such and such, overcast with visibility and all that kind of stuff. You can do all that, and that'll help you paint the big picture. But if you go to this particular site, okay, it's going to give you a map of Florida with all of the weather forecasting sites that'll look just like this down here. So I'm going to go down here once again to new share. I'm going to go back over to here. And now I'm going to go up to that weather site right there. And there's the map of Florida. That's on one of those URLs I showed you. And you can move your mouse scroll button and zoom into the area. And you'll notice that there's 3 weather reporting stations. There's one up here. It's called Biolab Boat Ramp. And that is up north of and right in the middle of the Canaveral National Wildlife Area. Over here in Titusville, so named because it's in Titusville. And then down here is the EFSC Planetarium and Observatory. So whichever one you want to use, and you might want to look at all 3, because if the weather is going to be great up north and lousy to the south or the other way around, you might want to have that influence the decision on which direction you want to shoot the rocket. If the clouds are going to be up north, you may not want to be up north. You may want to be down here at the Cocoa Beach Pier and get the streak with the clouds as a background. So those are the types of decisions that this will help you make. So you click on this and up pops this little bar, and then you click on this link that's in here where it says Titusville, and up comes the current Titusville clear sky chart. There's a whole bunch of stuff here on how do you read it, cloud cover, 80% covered all the way down to 10% covered or clear. Okay, obviously you would prefer clear. Transparency is how transparent is the air. If it's very going to be a lot of particulate matter in the air, a lot of humidity, you'd be below average, poor, somewhere down in there. Seeing, you don't have to worry about. Darkness, you do, but you don't. You already know that. Smoke, you would like to know, but it's very rarely an issue. Wind, it's nice to know. Wind to me means a lot because if it's 0 to 5 miles per hour, I bring mosquito spray. If it's above 11 miles per hour, I don't bother with mosquito spray. Humidity, again, the higher the humidity, the more fuzzy the streak is going to look. But anyway, the important part is right here. So here we are, it's Saturday. We're looking for Sunday between 2 and 3 in the morning. So there's 2, there's 3. And if you follow my little cursor there, okay, at 2 o'clock in the morning in Titusville, the sky is going to be clear. At 3 o'clock, it's going to be clear. Above average transparency, average to above average transparency, seeing, but it's going to be dark. Okay. There's not going to be any smoke. The wind is going to be 6 to 11. Good chance the mosquitoes won't bother me. Humidity is going to be low, and the temperature is going to be in this 68 to 77. So you can use this based on the time of day, and it forecasts out about 2.5 days. And this is great to start making early decisions on where you want to go or whether you even want to bother. Okay. So this particular clear sky chart capability is great, along with any other weather forecasting that you may use. Anybody have any question on this? Okay. I'm going to go back here. So you see that each reporting point is a link to the particular chart, and that's what that slide's all about. Okay. Those are the tools I use. That's how I do it. So I am going to break in now. Oh my God, there's more people here. I'm going to break in now and see how many questions we have. Teeny, I can see you're sitting there with lots of questions all over your face. I can tell, I can see it. So who's got questions?
Hey, Gordie,
Yes, sir.
what time does the Milky Way come up this tomorrow morning?
The Milky Way comes up every morning. The best way to find the Milky Way, there's a standalone program that I have on my computer that shows me the Milky Way, and it changes throughout the month and throughout the year. Oh, Walter, hey, stop the barking. He's a dachshund.
One
God
thing to know with
almighty.
the Milky Way, it rises higher in the summertime. So June, July, a
Right.
little bit into August, it'll be very high into the sky, raises high. The more towards winter, it comes up, but you don't see a whole lot of it.
Yeah. Well,
So this is right in between that time frame.
the program is called Stellarium. I'm going to load it here and just for half a second, if I can bring it up too quickly here. You guys won't see it until I share it, so just stand by. I am going to load this. Okay, now I've got too many of these little bars that pop up at goofy times. All right. I'm going to show this to you because the shot I took with the Milky Way in the background, this is what I used to know exactly where the Milky Way was going to be. And Richard brings up a good point. We talk about the Milky Way as if it's a singular point or a singular cluster of stars. The Milky Way is up all the time and it's all around us. When we talk about the Milky Way, it's kind of a colloquial way of saying the core of the galaxy. The core of the Milky Way is in one direction, but there's a whole bunch of Milky Way behind us. We just don't usually see it. Okay, let me go here. All right, this is Stellarium. Can everybody see that? And I am looking northeast right now, and this is the current time. So I'm going to go over here and I'm going to change my date and time. And I am going to motor this through hour by hour. Okay. So there you're beginning to see the core of the Milky Way. And that says if I was looking southeast, between east and southeast, at about, well, there's midnight. Okay. The core is just barely above the horizon at midnight, looking to the southeast. Okay. There's 1 o'clock in the morning. And you can see the core is just probably 20 degrees above the horizon, right in there. And again, looking to the southeast. And as I zoom out, you can see there's the arch of the Milky Way. And that's what you would see if it was dark. Unfortunately, it's not dark. Our little hometown of Melbourne wipes out this Milky Way. That's why when I went up north of the Canaveral National Seashore and looked out to sea back in early April, this was significantly further to the left. Okay, it was maybe 30 or 40 degrees further to the left, and it was out over the ocean. So there's no cities to give me light pollution or anything else. So that's why I got a good Milky Way shot with the streak going through it, because I was looking out over the ocean. So, Ann, does that answer your question?
Yes, thank you.
Okay. So I'm back here. That's how I find it. Now, I'm sure there's other ways to do it, but that's how I find it. So what else is there?
How long have you been doing this and how many times have you captured the flight path?
I got the job here at Cape Canaveral in July of 2016. So coming up on almost 5 years. And I've been shooting a lot of my early shots. Hang on. A lot of, damn dog. A lot of my earlier shots, I spent time shooting the launch at the launch pad itself, which I still do if it's a daytime launch and I'm not sitting on the console. But if it's a nighttime launch, I started doing the streak shots 2-3 years ago, and I've got a whole bunch of them. I've got them all over the place. I started really seriously doing the foreground and the light painting and that after watching a guy from Australia do nighttime celestial shooting and light painting. A guy by the name of Richard Tatti, T-A-T-T-I. If anybody is a YouTube junkie, look him up. You will spend an entire weekend watching his videos. He's absolutely terrific. Richard Tatti is his name, but he's an Australian guy, real good bloke, and he is the master of light painting at night with flat. He calls it a torch. You got to get past that. But anyway, he's the master at using a flashlight to light your foreground or your subject or whatever, and then let the stars or the Milky Way or whatever come into the background. So
I did not realize that you work for the Cape.
for the Air Force, yes.
You work for the Air Force, and what is your position that you do for them?
Well, I'm about every third launch, sometimes every fourth launch, but every third launch or so, I'm the Emergency Operations Center Director. So I'm in charge of, if anything doesn't go right, I own it. So every time there's a launch when I'm on console, I got my fingers crossed that everything's going to go right, because I don't want to get involved. But if it does, I own the fire department. I own the security, the whole shooting match. And the Emergency Operations Center, we stand it up, and I have people from fire, civil engineering, security, emergency explosive ordnance disposal, Coast Guard, whoever the shooter is, public affairs, safety, bioenvironmental engineering, and EM technicians. So I got all those people that are manning the consoles at the EOC, just in case something goes wrong. So that's what I do.
Wow, I had no idea you did all that.
So you push the button then.
Yeah. Okay, what else? I am going to stop this recording because God knows